has made her presence felt. We currently have a barometric pressure of 985 millibars, so we know that the eye is getting close. If you see behind me, just look at that scene. That's hurricane right there, baby.
It wasn't the kind that tears roofs off in seconds or hurls cars like toys. But in August 2011, Hurricane Irene revealed something even more chilling. You don't need maximum wind to cause maximum chaos. Between August 21st and 28th, Irene marched up the east coast of the United States like a slow-moving siege engine, threatening nearly 100 million people, 1/3 of the country's population. Airports shut down, subways went silent. New York City, the city that never sleeps, braced for the unthinkable. And while Irene's winds topped out at around 120 miles per hour, it wasn't the wind that brought catastrophe. It was the water. In Vermont, rivers raged like they hadn't in centuries, sweeping away covered bridges that had stood since the Civil War. In New Jersey, entire neighborhoods drowned under 7 feet of floodwater. And across New England, streets turned into rivers, power grids collapsed, and families watched as homes they had lived in for generations disappeared beneath the deluge. By the time Irene's final rains fell, 49 lives were gone. The cost, over $14 billion in damages. Yet, Irene remains infamous not because of the number beside its name, Category 1, but because it exposed a chilling truth. Before Irene brought devastation to towns and rewrote maps, it was just a swirl of clouds. Today, we're tracing how that swirl evolved into catastrophe and why, despite all our technology, we still couldn't stop the destruction it left behind. When most of us picture a hurricane, we see the satellite swirl, a perfect white spiral stretching across hundreds of miles. But satellites like NASA's TRMM mission revealed something far more dramatic inside Hurricane Irene in 2011. A towering three-dimensional monster with hidden lightning, hot towers of cloud punching 9 miles into the sky, and storm cells literally feeding the beast from within. Here's what made Irene so fascinating and so dangerous. On August 21st, Irene was just a tropical storm, but TRMM's radar caught something ominous, a hot tower soaring nearly 10 miles high. These hot towers are like rocket fuel for a storm, pumping latent heat into their center. And sure enough, lightning was sparking through Irene's inner core, a warning sign of powerful updrafts and giant ice particles swirling in the sky. In hurricane science, lightning is like a red flag. It often means the storm is gearing up to get stronger. By August 23rd, Irene had reached Category 1. TRMM showed that the storm's eye wall, the ring of clouds circling the eye, had completely closed. That's the moment a storm stops wobbling and starts tightening its grip. On the eastern edge, bursts of intense convection were exploding upward, feeding energy into Irene like a blacksmith pumping oxygen into fire. Within 12 hours, those bursts would help propel Irene into a Category 3 hurricane. And then came the eyewall lightning. Normally, hurricane eyewalls are strangely calm when it comes to flashes, but Irene broke the rule. TRMM spotted lightning bolts inside the eyewall itself on August 24th. That meant something unusual. The storm wasn't just mature, it was still boiling with energy. Irene had leveled up. It was no longer just a hurricane, but had crossed into major territory, a Category 3 storm with the power to shred everything in its path. TRMM's radar revealed something especially ominous, a tight, compact eyewall with hints that a second outer eyewall was starting to form. In hurricane science, that's like watching a storm reinvent itself. These double eyewalls often signal an eyewall replacement cycle, a mysterious process that can suddenly shift a storm's intensity, either dialing it down or unleashing something even more dangerous. And then came the lightning. Flashes inside Irene's eyewall, normally rare in such storms, were proof that enormous energy was still being pumped from the ocean into the sky. In other words, Irene wasn't finished growing, it was still charging. But the real danger wasn't just in Irene's howling winds or crackling lightning. It was in the way the storm broke the rules. On paper, Irene shouldn't have been this bad. By the time it reached the US, its winds had slowed, its category had dropped, and forecasters were breathing just a little easier. But storms have a way of changing when you least expect it. You see, Irene didn't need record-breaking winds to wreak havoc. It found another way. What made Irene so destructive was a chain of rare atmospheric quirks that gave it staying power and reach. As it spun over the Bahamas, Irene was already feeding off a banquet of warm, moist air, rising from unusually low pressure, a perfect fuel source. Winds screamed at 115 miles per hour, the mark of a Category 3 powerhouse, and for a moment it looked like the US would take the full brunt of it. But then something unexpected happened. As Irene neared North Carolina, it slammed into a wall of dry air blowing in off the coast. The storm's winds dropped to Category 1 levels. It looked like good news, except it wasn't. That dry air didn't kill Irene, it stretched it. The storm ballooned outward, sprawling across hundreds of miles. The winds weren't as fast, but they covered far more ground. It affected a lot more people than would have been the case if it had been a smaller storm, explained Keith Blackwell of the University of South Alabama's Coastal Weather Research Center. In other words, Irene traded raw speed for reach, and millions more people were suddenly in its path. Just when it looked like Irene might finally be running out of steam, nature threw in another twist. High above the Atlantic, the jet stream was waiting. Think of it as a razor-sharp current of air, the kind that often slices storms to ribbons and scatters their swirling towers into nothing. If Irene had drifted a little closer, that might have been the end of her. But instead, the jet stream became her unlikely ally. It hovered just far enough away to avoid shredding the storm, yet close enough to pull her north, almost like a conveyor belt, while helping Irene hold on to a pressure so low it didn't even make sense for a storm that had already weakened to Category 1. And that low pressure was everything. It was the engine that let Irene cheat the rules. Normally, once a hurricane's winds slow and it drifts inland, the storm collapses. Irene should have fizzled. Instead, her abnormally low pressure kept drawing in warm, moist air, feeding her system and keeping her alive as she churned up the East Coast. By the time she brushed against New York City, her winds had dropped to 65 miles an hour, barely tropical storm strength. But here's the thing, her pressure was still at 965 millibars. That's nearly identical to what Hurricane Wilma packed when it tore into the Florida Keys as a Category 3 monster in 2005. So even as Irene lost speed, she held on to dangerous force. And when she finally limped into Canada with winds of just 45 miles an hour, it wasn't weakness that made her unforgettable. It was how many times she should have died and didn't. That refusal to die made Irene something else entirely. Not just a storm to track, but a threat people could feel in their bones. In the days before Irene made landfall, the East Coast was buzzing with a nervous energy. Supermarket shelves were stripped bare. Gas stations saw lines curling around blocks. Families loaded cars with whatever they could grab. Pets, suitcases, heirlooms, while traffic crawled inland. For once, people weren't waiting to see what would happen. They were already on the move. And that reaction was anything but guaranteed. Just 6 years earlier, Hurricane Katrina had shown what happens when warnings go ignored. In New Orleans, many stayed put, believing they'd ridden out hurricanes before and could do it again. But Katrina had a weapon few truly understood: the storm surge. Not just flooding, but a 20-foot wall of ocean water bulldozing its way across the Gulf Coast. It didn't just rise, but devoured, swallowing neighborhoods and rewriting the map of an entire city. That memory lingered, and when Irene started to climb the coast, people remembered what ignoring the danger could cost. Governors didn't hesitate to declare states of emergency.
The Emergency Operations Center has been activated. We've been preparing. Before I entered the room, I signed a declaration of a state of emergency in anticipation of what's going to be happening. That will allow General Reith to begin to deploy National Guard resources throughout the state immediately, and he is begun to execute on those orders, which I just signed.
Evacuation orders came fast. This time, people heeded the call. New York City had seen hurricanes before, but Irene was different. Storm surge. Two words that mean the ocean itself is coming for you. If Irene pushed even slightly harder, walls of water could swallow subway tunnels, flood power grids, and turn lower Manhattan into a bowl of seawater. Mayor Michael Bloomberg didn't wait to gamble. Nearly 370,000 residents in low-lying neighborhoods, Coney Island, the Rockaways, and Staten Island, were told to leave. It was the largest evacuation order in the city's modern history. Some thought it was overkill, but if Katrina had shown anything, it was that waiting could be fatal. By the time Irene clawed her way into Brooklyn, she had already touched down in North Carolina and New Jersey, and her status had dropped to a tropical storm. The feared 8-foot surges never came. Instead, the waters peaked around 5 feet, less than predicted, but still powerful enough to remind the city how fragile its coastlines really are. Now, some critics scoffed. Was it really necessary to uproot nearly 400,000 people? Meteorologist Gutowski had a different take. There could have been a small shift in the storm, and storm surges could have been much worse. In other words, Irene's mercy was luck, and yet, luck has no place on the official scorecard. Hurricanes aren't judged by mercy or missteps. They're ranked by raw power, a scale built to capture just how monstrous they can become. The Saffir-Simpson Hurricane Wind Scale, stretching from Category 1's damaging winds to the apocalyptic fury of Category 5, where gusts can top 157 miles per hour. Irene, at its peak in the Caribbean, reached Category 3 strength, with winds screaming between 111 and 129 miles per hour. For the islands in its path, that meant disaster. Power grids collapsed, streets vanished beneath floodwaters, at least 8 lives were lost, and the price tag of Irene's Caribbean rampage climbed to more than $370 million before the storm turned its sights north. Florida got a lucky break. The worst of Irene skirted past, leaving only heavy rain, pounding surf, and a taste of the chaos to come. But farther up the coast, Irene began leaving scars. In South Carolina, beaches were chewed away by the surf, streets turned into rivers, and trees toppled into homes and power lines. Thousands were plunged into darkness, and the storm left behind at least $5 million in damages, just a fraction of what was still ahead as Irene crept toward the heart of the eastern seaboard. When Irene finally struck the U.S. mainland, it came ashore near Cape Lookout on North Carolina's Outer Banks as a Category 1 hurricane. Even at that weaker status, the storm left a trail of devastation. 7 lives lost and more than $1.2 billion in damages across the state. From there, Irene plowed into Virginia, where the heaviest blows weren't along the coast, but inland. Thousands of homes were battered, hundreds of roads washed out, and 5 more lives lost. Damages reached nearly $182 million. Even Washington, D.C., the nation's capital, couldn't escape the storm's reach, sustaining $15 million in property losses as government buildings and neighborhoods alike faced Irene's fury. Maryland was next, hit with more than $500 million in damage and 3 fatalities. In Delaware, 2 more lives were lost, with another $43 million in destruction. Pennsylvania saw rivers burst their banks and trees wrenched from the ground, leaving widespread flooding and power outages. 6 people passed away there, 3 from falling trees and 3 from other storm-related causes, with $58 million in damages left behind. But Irene wasn't done, not by a long shot. Instead of fizzling after North Carolina, the storm pulled one of its cruelest tricks, slipping back out to sea, regathering strength, and then lunging inland again. Not once, not twice, but 3 more times. Landfall number 2 was New Jersey near Atlantic City. By then, Irene was only a tropical storm, but don't let the downgrade fool you. She still packed winds near 70 miles per hour and dumped up to 10 inches of rain. 11 lives lost, $1 billion in destruction. Then came New York City, landfall number 3. A metropolis built on steel and stone, suddenly humbled by water. Streets turned into rivers, subways filled like bathtubs, power grids went dark. 10 more lives were taken, and $1.3 billion vanished in damage. And still, Irene pressed on. Connecticut took the 4th hit, towns drowned, infrastructure wrecked, and 2 lives lost. Another $235 million in damage carved into the record books. But Irene wasn't just striking coasts. Her outer bands lashed all of New England. Rhode Island took $104 million in damage. Massachusetts lost 1 resident and nearly $200 million in property. Vermont saw its hillsides crumble into torrents of water. 6 people passed away, $733 million gone. Even New Hampshire and Maine weren't spared. 3 more deaths, another $58 million burned away. By the time Irene limped into Canada as a post-tropical storm, Quebec added 1 more life lost and $130 million in losses. When it was finally over, Irene's trail stretched like a scar across half a continent. 4 landfalls, billions in damage, and 1 chilling reminder. Sometimes the most dangerous storms aren't the strongest. They're the ones that refuse to let go. By the time Irene had been stripped of its hurricane title and downgraded to a tropical storm, the real catastrophe was only just beginning. What it lost in wind speed, it made up for in water. Inland, the storm exploded rivers over their banks, drowning towns in New Jersey, Vermont, and Massachusetts. Roads buckled, bridges snapped, and railroad tracks twisted out of the ground. Houses that had stood for generations were ripped from their foundations in minutes. The storm didn't just strike homes and highways, it ate into the very fabric of local life. Fields of crops were ruined overnight. Tourist escapes in the Catskills and Adirondacks, usually preparing for their lucrative fall foliage season, were left broken and sodden. Even the coastline looked different, reshaped by storm surges that carved their way up from North Carolina. Lives were spared in large part because Irene had been forecast well in advance. People had time to stock up, evacuate, and find shelter. But survival came at a cost. More than 9 million people were thrust into darkness, some for days, others for weeks, as power grids collapsed across the Northeast. And then, before recovery could even begin, another blow landed. Tropical Storm Lee swept through just days later, wringing out record-breaking floods across Pennsylvania, New York, and New England, turning Irene's aftermath into a prolonged disaster season. In the end, Irene left behind more than $14 billion in damage and at least 49 lives lost. It was a storm that didn't just strike once, it reshaped how Americans understood hurricanes in the Northeast. Irene proved that disaster isn't only measured by wind speed or storm surge. Sometimes the true devastation comes from what lingers long after the skies clear. But here's the good thing about catastrophe. It teaches us. And Hurricane Irene, for all its devastation, was also a great teacher. In the 13 years since Irene carved its path of destruction across the Northeast, science hasn't stood still. NOAA has revolutionized hurricane forecasting with the Hurricane Analysis and Forecast System, or HAFS, which became operational in 2023. This next-generation model uses storm-following technology that acts like a magnifying glass, giving forecasters an unprecedented view into a hurricane's eye wall, wind fields, and structure. In 2024, HAFS contributed skillful forecasts, including useful rapid intensification guidance for storms such as Helene and Milton, giving forecasters better lead time to warn communities so they had more time than ever before to prepare. But perhaps most exciting of all, AI has started to play a role in forecasting. DeepMind's research models have outperformed conventional models in benchmark tests, and real-time trials and collaborations with U.S. agencies are underway, signaling that AI could significantly boost forecasting capability if carefully integrated. The National Hurricane Center has begun incorporating AI tools into their forecasts, and experts believe these technologies could one day make 10-day storm forecasts as accurate as today's 5-day predictions. The lessons weren't just technological. Vermont didn't just rebuild after Irene, it rethought how to live with its rivers. The state pushed culvert and road upgrades, ran buyout programs for repeatedly flooded homes, and participated in interagency programs to coordinate flood risk reduction across agencies. Vermont created its own detailed flood maps when FEMA's outdated maps proved inadequate, and integrated climate science directly into policy decisions. Roads and bridges were rebuilt to withstand future floods, and power companies began decentralizing their grids to make outages easier to contain and recover from. New Hampshire created an internal emergency and flood response group, began conducting agency-wide disaster exercises, and formed partnerships with communities to assess infrastructure at greatest risk during future flooding. Emergency managers learned the critical importance of having Plan C for your Plan B, and developed more robust communication systems that don't fail when they're needed most. The improvements extend far beyond individual states. Between 2007 and 2020, hurricane forecast errors have decreased by well over 40%. Better forecasting means real savings. We're talking on the scale of billions of dollars in reduced damages per hurricane. Globally, the United Nations launched the Early Warnings for All initiative in 2022, aiming to protect every person on Earth with early warning systems by 2027. Since 2015, the number of countries with early warning systems has doubled to 101 nations. Hurricane Irene proved that sometimes the most dangerous storms aren't the strongest. They're the ones that refuse to quit. But it also proved something else, that we refuse to quit too. Every upgrade, every improved forecast, every rebuilt bridge stronger than before is a testament to human resilience and our determination to protect the lives that matter most. The next time nature sends us a storm that breaks the rules, we'll be ready with better science, stronger infrastructure, and the hard-won wisdom that only catastrophe can teach. Thanks for watching another episode from Natural Forces. If this deep dive into Hurricane Irene fascinated you, you'll love our other explorations of nature's most powerful phenomena. Hit that subscribe button so you won't miss our latest videos uncovering the forces that shape our world. Until next time, stay curious, stay prepared, and remember, understanding nature's power is the first step to surviving it.